This morning I had a phone call from a fellow named Rocky, and Rocky had a dilemma. He has a NuTone NM100, and he was messing around with it trying to figure out how to hook up one of these Wi-Fi video doorbells. During the messing around, there was a spark, and then the system went dead, and he figured out that the fuse in the transformer blew and the transformer went dead. He followed my video that shows how to replace the fuse, and I'll remember to put in a link, one of those pop-up things right up in here somewhere that you can watch to see what that's all about. He didn't have the right fuse, or any fuse, I think. So he temporarily bypassed the fuse, which I don't recommend you do. It's a safety hazard. You could burn your house down, so please don't do that. After he put that back together, he still didn't get any output from the transformer, and he was wondering if he somehow blew the transformer up. And the answer would be most likely, no, I don't think so. The transformers are pretty robust, and I don't think a very brief short would have caused something like that. He had already found a replacement transformer online, and he ordered it, and he's waiting for it to come in. And one of the things I pointed out to him, the dilemma he's going to have is, did the fuse in the transformer blow because his messing around with the back of the set shorted something, and that's what caused the fuse to blow? Or did his messing around on the back of the set cause some kind of damage, and that damage is what caused the fuse to blow? And there's a difference between those two things. If he was messing around and caused some kind of temporary short-term short and it blew the fuse, once he stopped messing around, the short was gone, and that was that. And if you fix the fuse, it should all work. But if he damaged something during the messing around, the damage is still there even though he stopped doing anything to it. The dilemma you get into is, okay, you spent money to buy this brand new replacement transformer, and it's just like the original transformer, and it has a fuse in it. So what happens if you put your brand new transformer in and you plug it into the master station and the damage is still here? It's just going to instantly blow the fuse and you're right back where you started. And that's a difficult thing to do. When we get calls like this, we have ways to deal with this, but then we're the people that show up in the big van full of NuTone stuff, and we're well equipped to deal with pretty much anything that we run across, and we have our ways of doing things to bypass those dilemmas. But the average person doesn't have that. So I was thinking about it after I got off the phone from him. This is one of those kinds of things that it seems plainly obvious to me, but it's not to everyone else because I've done this for a long time. The easiest way to try to tilt it in your favor is by doing some basic testing and measuring on the master station without it even being powered up. If we flip this around, because we care about the back side more than the front side. Oh, and just for those of you who are paying attention, this is an NM200, but it's the same either way. And I should point out that the NM100, the NM200, and the IM and IMA 4406s are the only models that NuTone ever made that have transformers that have fuses in them. And what I'm going to show you today is specifically for the NM100, NM200. I'm going to make a different video about the 4406 series because there are some differences in how that's going to go. The part we care about is this part right here. This is the power cable with the multi-pin Molex connector on the end of it, and this is what the transformer plugs into. The transformer has the mating half of this plug, and you plug them together, and that's how the set gets powered. We can use this along with our multimeter to do a very basic measurement to see if there's a long-term problem or damage that's happened to Rocky's NM100. And I'm doing this today with our example multimeter. This is an X-Tech EX330. I've done a review video about this. It's a reasonably inexpensive multimeter. I think it's gone up a little bit in cost since I made the review video, but like everything, that was probably 4 or 5 years ago, and everything goes up a little bit every year. It's still a reasonably priced multimeter. If you need something like this, it's highly recommended. It's about 40 bucks on Amazon, so it's not a lot of money to spend. What we're going to do is we're going to use the multimeter and we're going to put it in the ohms range, which is one click over. And I'll try to set this up so you can actually see the display. We're going to use our mode button and we're going to put it in continuity mode. So continuity measures whether any kind of circuit is complete. Let's take as an example a piece of wire. So you take one probe and you put it on one end of the wire, the other probe on the other end of the wire, and if the wire is not broken, you have continuity. It's like touching the probes together. If you have a break in the wire, there's no continuity, so there's no continuity. So we're going to use this, we're going to put it in continuity mode, and we're going to put it in continuity mode with the little beeper symbol that comes up right here that you may or may not be able to see, but it does. And what happens is, when you touch these together, it beeps. It gives you also a resistance reading. Here it looks like 13 point, now it's going down. It's 3.2, 2.7, it's going down in ohms, and eventually it will settle out at the lowest possible number it can. It looks like it's right between 1.7, 1.8, now it's 1.2. Maybe because I jostled it around a little bit, but somewhere in that range. And what you're actually measuring is the resistance of the wire leads that are connected to the probes. So that's fine. What we really care about is, we don't care about the ohms measurement so much, we care about whether it beeps or not. And granted, it's got a kind of weeny kind of little beep going there, but it's, for this example, it's good enough. Now, how are we going to do? Well, we're going to use it on our multi-pin connection, or connector. Now, this connector is a little unusual in the way it's laid out. There are a total of 5 wires in it, and if you look on the label on the top of the transformer plate, it shows which pins are which numbers and what voltage you should measure between those pins. Now, I happen to know this because it's what I do, and I know the pins are, on this side there's 3 wires, and on the other side there are 2 wires, one of them being a ground, which we don't care about. And so it's numbers 1 and 2 and 3, and on this side the red wire in the center is actually 5. And that's what it shows on the label on the transformer plate. I didn't write numbers in because it's too small, and I'm doing this to make a video and it's too hard to write upside down. But so I made dots. Dots are a valid way to do it. 1 dot's 1, 2 dots, 3 dots, 5 dots. Makes it easy, don't you think? So the transformer label says that the connections are 1 and 2 and 3 and 5. And I think it's 16.8 volts or something. It doesn't matter what the voltage is of the transformer, because we're not testing the transformer, we're testing the NM100 or NM200. If everything in the master station is good, and there are no shorts in the master station, there should be no continuity between the appropriate pins, 1 and 2, 3 and 5. Got that? Let's do that one more time. If there's no short in the master station, if everything here is good and there's no damage, there would be no continuity between 1 and 2 and then 3 and 5. How do I know that? Well, you have to backtrack what happened. Something happened in the master station when Rocky was messing around with it, and it caused some sort of problem. What that problem may or may not be, I can't tell you because I've never seen the set, but whatever the problem was, it was a heavy duty enough problem that it blew the fuse in the transformer. Okay, so when does a fuse blow? A fuse blows when it's overloaded. When too much power goes through the fuse, then the fuse overheats, it melts, and it blows. Just like if you plug something in the wall outlet in your house and it's way too big, let's say you're on a 15 amp circuit and you plug in a hair dryer that uses 25 amps, you turn on the hair dryer, it's going to kick the breaker or blow the fuse because it's using more power than the circuit breaker can allow. If we take our meter in continuity mode, remember, so it beeps, as weenie as that is, if we very carefully put the probes between 1 and 2, and it's hard to do in the video and show you. I'm going to jam them in here and then hold it up and see if you can see, like that. Now you notice I'm measuring on the back sides where the wires go in because you can see the metal that's crimped onto the ends of the wire. You can also do it inside on the pins if you want to. You just have to make sure that the probe leads don't cross over the pins and you get a false reading. So if you jam it in here, we're getting no beep and no resistance measurement on the meter. See, OL, over limit, no resistance, no beep. That's good. And then if we do 3 and 5, like this, oh look, I got them jammed in further, now they stay better. So now we're on 3 and 5, it still shows over limit and no beep, which means no continuity, which means no short in the master station. Now this is my master station, this is not Rocky's master station. But the idea is, if he caused some kind of severe damage to his NM100 and there's a short in the master station, either on one set of power inputs or the other set of power inputs, when you put the probes into the plug-in, if there's a short, it's going to show continuity because a continuity is a closure, is a short, and it's going to show some kind of resistance. What kind of resistance is it going to show? I don't have any idea because it depends on what happened to it. But this is sort of a basic test that you can use that gets you over the dilemma of, I did something to my intercom, I spent money to buy a new transformer, now I've got the new transformer, but I don't know if I should plug it into the set or not because I don't want to blow up the transformer I just bought. And that's a valid concern. That's a dilemma that nobody wants to face because you only get a split second of the transformer went from good to bad, and then you're right back to where you started. And that's kind of a pain in the neck. Now, I'm going to try not to get geeky here, but I'm going to explain two concepts about multimeters that if you understand it, you'll be better off. So we're going to take it out of continuity mode, and now we're just in resistance measurement or ohm mode. So no more beep, but if we touch the probes together, we're showing it's measuring 0.4 ohms, 1/2 of 1 ohm. Okay, so that again, it's measuring the resistance in the wire leads that are connected to the probes. If the wire leads were better quality or shorter or whatever, you might, or if the meter was better quality, okay, if you instead of spending $40, you spent $400 on it, you might actually read 0.0. You might read nothing. And it's 0 ohms. 0 ohms is the same as continuity, but 0 ohms is not the same as over limit. Over limit, OL, is a thing that most multimeters show when there's no continuity. You can't read it because there's nothing to read because there's no connection. This is a little bit confusing, especially if you don't use a multimeter all the time. But over limit means no connection. Something close to 0 ohms mean that there is a connection. And that's a distinction that you have to make. The other thing which you will see, and the reason why I chose to use the X-Tech for this video instead of my Agilent Keysight, used to be Hewlett-Packard, bench multimeter, is because my bench multimeter is a $2,000 bench multimeter. And a $2,000 bench multimeter, it will measure some resistance when you connect it to the wires in the plug. What kind of resistance is this going to measure? Well, it could possibly measure something like 1.6 million ohms. And when people see 1.6 M or 1.6 million or however your really expensive multimeter shows it, they're going to freak out because it's like, oh my God, I got 1.6 million ohms inside my NM100. What does that mean? Okay, it doesn't mean anything. Dead short is 0. So you put the probes together, a dead short is about 0 ohms. 1.6 million is so far down the road from 0 going that way that the 1.6 million ohms is like the tiniest tiny dot on the horizon of ohms. It's so far away and it's so incredibly tiny that it doesn't really mean anything. What it really means is that you got some really kick-ass multimeter if you can measure that on something like this. Don't worry about the 1.6 M on a really expensive multimeter because it doesn't really apply. And that's as geeky as I'm going to get. You know, you could spend, if you play with a multimeter and you do it every single day, you could spend years figuring out everything that you can do with it and what all of it actually means, and that's not really what this video is about. So don't worry about it. All you care about is, do you have continuity? Is there a dead short in your NM100? Because when you put the probes in the socket, it beeps and it shows 0. And that's what you don't want. And that was a way I came up with after I talked to Rocky on the phone about how he could test his NM100 before plugging in his new transformer and blowing it up. Now, is this absolutely for certain going to work every single time? No, probably not. But it's the best that you can do unless you have more and more equipment than the average homeowner would have to try to tip it in your favor and not blow up your brand new transformer. That's it. And I made this primarily for Rocky. I sent him an email after I talked to him when I thought about how to do this, but I thought this would illustrate it perhaps a little better. I hope you found this interesting, and perhaps for some of you it will be helpful. There will be a follow-up video to this one about the 4406 because it's a little different than this one. If you did find it interesting and helpful, please give it a thumbs up on YouTube, because that helps us a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.